Hey everyone, it's Dr. Lucien, and this is the supplemental review video for Module 5. So in the lecture video itself, we had a different layout for the readings. I actually moved two more down. You still have to, on your own, review 1, 2, 3, 4, 5, but I'm going to try to review these other things and kind of supplement some of the things I had talked about. I hope you don't mind. So let's go ahead, and I'm going to skip down to the OSHA and the Bureau of Labor Statistics. These used to be really large portions of Lecture 5, but I moved them out to bring in more of the work I had done and published with Mike Wolf, and some of the SIFs things as well, and I'm going to discuss that. So first, OSHA record keeping. Hopefully you do know what this is. If you don't, this is the OSHA website, and you can go check it out. All the record-keeping information is, kept under 1904, which if you need to find that, it's under standards and then laws and regulations and then record-keeping. But I'm going to go to the record-keeping page here because that's really what I talk about, especially when it comes to electronic submissions. You have to submit your 300A. If you don't know what the 300A is, we can go down here. We can click on this and you can look at it. It's the annual summary. 301 is the first report of injury. That's your accident investigation form. The 300 is the log, log of injuries and illnesses, and then 300A is the annual summary. And you're required to complete that. Somebody, a corporate level person has to review it and sign off on it, and then you have to post it. Is it February 1st through April 30th? Oh, now I'm questioning myself. Where's my 300A? Because it says right on the bottom of it. 300A, posting February 1st through April 30th. Okay. Testing myself. So if you are going to be keeping the company's injury and illness data, the OSHA record keeping data, you also need to upload the data to the injury tracking application. You have to create an account. It has to be verified. You have to do a verification, and then you enter your information. And that's due by March 1st of every year. And if you're a larger company, I think over 250 employees, then you're required to actually upload your 300 and 301s. And so that's all here. I'm not training you on OSHA record keeping. I just want you to know this is where it is. And the data that I analyzed for my paper can be found under data, I believe. And the injury tracking application current data. Okay, so here's the 2023 stuff. I just did the 2016 right here to 2022. So I downloaded all these data sets and analyzed them. So this is all good information. Now they do have a summary that you can take a look at. That's under a zip. Summary dictionary, case detail. Is this it? Oh, it's a zip. I don't want to look at it. But anyway, it's not very clear. It's very high level stuff you don't need. I'm sorry. It just is. In my paper, I break it down. I'm actually working on a second manuscript right now. Maybe added. I may have to redo this next year when I teach this. Let's go to the Bureau of Labor Statistics now. This is where I have a problem. Because what they do is if you go to the, you can go look at the industry incidence rates. I can just click on that. It's got Table 1 from the SOI report. This is for 2023. And you can see here all industries, including private, state, and local governments. Their total case incidence rate is 2.7. Their DART is 1.5. But that's the average. Now, what does the average mean? And I had said this in the lecture video. If it's a non-normal data set, then the average means nothing. And what you should be reporting is the extremes, the median, the mode, and the average. But they don't do that. And if they're calculating as an incidence rate, that's just totally wrong. I think that's how they're doing it based on what they have. Because if they said here, these are the average of each individual submission, then you'd be able to generate that other data. But they aren't. They're only providing this, which makes me think is they add up everything, multiply by 200,000 divided by total hours estimated. I think that's what they're doing. And I don't think you can do that. I think it has problems. Now, as far as the data itself, you can go in here, you can look at fatality stuff, you can look at state, data request numbers. When it gets into methods, this was, you can start looking at some of these other things. I'm not real satisfied with what they put in. They just kind of be, just trust us. And they do have a few things here. So if anybody is interested in learning more about how the Bureau of Labor Statistics collects and analyzes their data, you can look here. I just feel like they're statisticians and they're not practitioners like we are. And so therefore they look at the data as being a data set and not a representation of the people who are getting injured and killed during the course of their job and what that means. So yeah, all this stuff, it could be so much better. It really could. But let's not get too much into it. I just want you to make you aware that this site exists. Okay. All right. Now let's get on to the paper reviews. 5 3/4 minutes in. So this is one of my most popular, most downloaded and cited papers. Unfortunately, it was my first one. And this was when I was in grad school working for the Center it was CQPI, Center for Quality Productivity Improvement. Oh, it's right there. And what I was asked to do was a literature review, an extensive literature review, analyzing the how quality and safety are defined, and how quality management and safety management are defined, and how that might fit into the basic construct of construction work. And it's a decent review. I spent a lot of time before I knew what I was doing. I read all the work and wrote it out, and then I had to go back and redo it. So this was a trial for me. But I reviewed all this work and kind of broke things down, and I came up with this figure. This is my figure of the elements of a successful safety management program and elements of a successful quality management program, and then how they are similar both in their design, and you can see similarities in their output. So indeed, there are enough similarities that we should consider it. And then by breaking down and doing an extensive literature review, as you can see here, this is most of the paper. So don't get intimidated by it being 43 pages, because over half of it is my data tables. That basically, there seems to be really good promise here. And I mean, this was like 2003 and 4, I think. And I took this and I built it into my approach to OSHA record keeping, my data analysis technique I use for work comp data, and now some of it I'm generating new work. Essentially, construction is such a unique field that, can something like a quality management approach to the safety management actually improve the things because of the variability, the volatility of a site? And I think so. I think it's actually, it's something that is needed because it is so complex and always changing. Anyway, so that's a paper I wrote. What did we learn from it? Yeah. They're similar enough that it should be done, especially in construction, but I think it's easier to see in general industry. You're speaking to the author. Okay, what's interesting about this, there's a course on system safety. I'm a trained engineer. I can see why they built system safety techniques so that engineers don't forget that there are people and operators and technicians and maintenance people in a process. And so they came up with these techniques to give engineers a way to provide numbers, numerically think about it. This is a military standard. And how do I want to say this but be politically correct? Engineers are very good with numbers. They're very good with design and calculations and inputs and outputs and efficiency and transition rates, production rates, things like that. They don't understand people. They don't understand the human element. And that's what we've talked about a lot in this class. So they give them these different techniques so they can try to understand where something could go wrong, or trying to prevent a bad event from occurring. But the problem is they don't always understand. They may think, oh, we'll just have a buzzer go off, or we'll have a release valve, or we'll do something that'll try to either be a contingency, a redundancy, but they don't always think about what the workers need or where they may be or how they would have to evacuate if that was one of the options. And so this is a primer. So it just basically simplifies things. Perfect example would be Fred Manuel, pure engineer, great mind, thinks a lot about safety, does not understand the human element. In this class, think back to Frederick Taylor, Industrial Revolution. They had people standing in machines getting chewed up and eaten up. So, what they're doing is they're relating safety to some of the things that the engineers already know. Yeah. So the purpose of this is just to kind of give you an idea of the different types of techniques that are used, though it doesn't really spell them out in a way that you could apply them. It's just more of a general education and a defense of the need. Excuse me. So this is more of a breakdown of this particular military standard. Excuse me. So preliminary hazard list, preliminary hazard analysis, subsystem hazard analysis. It's just getting the engineers to think of something a little bit differently. And in doing so, maybe they'll spend more time with us or a subject matter expert so they can understand the human element or the operator element. But that's all it really is. It doesn't show the steps. It doesn't provide any case studies or examples, unfortunately. Give you some reference. This is still safety engineers. So this is an old document. So that's what I want you to get out of it, that engineers don't see people. I don't know if I said this in my lecture or not, but when I was an engineering intern, I had designed a system for recycling leftover metal from a stamping process. It was a molten injection, metal injection, and I studied the what would you call it? The metal ion percentages in the molten metal, and what's in an ingot and what's in the final overuse, because it changes a little bit. And so I calculated the optimum amount of fresh ingot to recycled metal material, to reduce the amount of ingot needed and reducing costs associated with getting rid of the leftover stuff and cleaning it up. But my design was for an operator to clean off and dump 50 pounds up over their head. I'd have injuries galore. I didn't think of that. I didn't know about safety back then. I was just thinking of chemical engineering. Anyway, next. This particular, so the link goes to this page here. And this is of interest, yeah. There's some other things you can look at, but this is the document that I want you to look at. It says right here, OSHA 3970. I'm glad that OSHA is starting to think about things like this, but they don't understand it yet. So when I was a compliance officer, I was trained to do VPP work. In Minnesota, it was called MinFirst. And so we had a modified form 33 in which we go in and analyze like management commitment, employee involvement, all that stuff. The problem is they oversimplify it. And in this class, I think you'll understand these things when we look at how they define it. So a leading indicator is something you measure to predict. It helps you predict what is going to occur. A lagging indicator is a measure of what has been done. Okay? Think of it that way. So some people say, a near miss is a leading indicator. No, the hell it is not. It's a lagging. It's already occurred. If you trend something like near misses, it may give you an indication of where to focus your attention, but that's not particularly a leading indicator. A leading indicator would be that you are completing work or measuring work that is safe, or measuring things that allow things to fail less. That's what a leading indicator is. And in the lecture, I kind of gave you some ideas of things I had done. I was doing ratios. So let's say my leading indicator is the number of corrections I can make based on employee reports per week. And let's say I try to do 10. If I'm fixing or repairing 10 things, or at least attending to it, yes, I will reduce the chance of an injury. That's a predictor. Is training? Well, it depends. I don't think just showing up to training is a leading indicator. I think people demonstrating that they can apply the training is a much better way to do it. And maybe you're using your training as a way to learn limitations to how you understand it. Okay? All right, so let's scroll through here. It talks about SMART goals. I agree with that. SMART goals are a good way to do it. It's the specific, measurable, accountable, reasonable, timely. Yeah. Okay. But that's goals. A measure itself, there's a difference between a goal and a measure, dude. Goals, yeah, are usually defined by a measure of some sort. So the goals are smart. The measures need to fall in and at least try to attend to these things. So here they talk about workers attending a safety meeting each month. Now, it's what occurs in that meeting. And just because they go to the meeting, nothing's going to change. They may discuss something, but it's what they do with that. Or it's what they learn, and does it apply? Does it actually alter their behavior? Or does it generate discussions you normally wouldn't? Does it make them feel better about their work? Does it improve their relationship with their coworkers and their supervisor? Do you guys see what I mean? It needs to be something that drives the good. And that's where I really like HOP and Safety 2.0 and Safety Differently, because that's what they're trying to do. So they never really lay them all out. They try to say, hey, pick one, figure out what you're going to do with it, and then plan, do, check, act. That's Deming. We talked about that in the lecture. All right, what else do they have here? They have attendance rate. Again, no, it's what you do while you're there and not that everybody gets it, okay? Let's see, attendance, inspection and clearing of walkways. Yeah, I mean, self-correction and reporting would be a good thing. Measuring people taking the time to clear things, measuring pride in people's work so they do keep it organized, I think is a good thing. But forcing people to do housekeeping, I mean, but it was out of place for a little while. So what if it was to injure someone when it's out of order? What if it remains in order because people take pride in their work? Maybe we should be measuring that. What's another one? Daily cleanups. Again, they're obsessing about the housekeeping because of that Smith paper. But when I talked to Dr. Smith about it, he said that the cleanliness is a reflection of workers' pride in their work, therefore keeping their workstations organized and clean. Not you clean, therefore things are safer. Number of incidents or injuries from trucks failing to stop. That's lagging. Arrival times. Number of back injuries from lifting patients. Using team versus not. Yeah, I guess that might be a little bit better. Is the percent in which a team lift is committed when it's supposed to. Arrivals past 5 minutes. All right, I can see that a little bit. I think they're edging up closer to what you should do. But so I'm saving you the time that this falls greatly short of where it should be, which to me is they're at least starting to acknowledge that there's a problem with measures, but they don't understand it yet. At least I don't think they do. What's this one? Percent monthly safety meetings, including a manager? Yeah, no. No. It's what's discussed and what the follow-up is. That, based on the monthly safety meeting, these things are going to be corrected in this amount of time or something like that. But what if nothing's wrong? Well, then we should talk about good things too. It shouldn't always be negative. And I do think if you're going to try and promote, a safe mindset, wanting to be agile and correct and learn, that you should be talking more about the positive things. Let's measure what are the positive things that tend to reduce the chance of somebody getting hurt. And open up communications in doing so. Yeah. So that's what I get out of the OSHA thing. It's a decent acknowledgement, poor execution, unfortunately. All right. The next one is, what is a serious injury? A model for defining serious injuries and fatalities, or SIFs. So I got to talk to some people in this group. Initially, I was against it, and I'm going to show you why in just a moment. But what they're basically doing is trying to understand or provide a definition. Because we really don't have a definition for near miss, but you kind of know when it's there. They're looking at serious injury, fatality, or potential. So it's a new classification, which I guess I can get down with that, because what do we have? We have death and then we have lost time. Or if you're talking about work comp, we're talking death benefits versus indemnified benefits versus medical only versus incident only or report only. So what they did is, their method is they basically got together a bunch of experts to kind of talk about it and come up with something. What do they call that? A Delphi technique? They don't call it that, but it's similar to a Delphi technique in which experts are the ones that it's a focus group. They discuss it. They try to come up with something. So here's some current definitions. Let's look at some of these. So an amputation. So this is the OSHA. Is this a SIF? An amputation could be anything beyond an avulsion, which is just ripping off the tip of your finger. I don't know. I think that this stuff needs to be defined better. Work injury that results in injured being placed on disability. I mean, that disability, that's just the doctor saying, don't work or don't lift something. It's a precautionary measure so the person can receive treatment until the doctor is satisfied enough to sign off and say they can go back to work full capacity. An amputation, loss of leg or arm, serious injury, fatality, and injury in your middle. It's all over the place, you guys. Hospital level injuries, injuries resulting in lost time. That the lost time is the doctor dictating whether they think they can go back or not, or the worker trying to get time off and convincing. So I don't believe in that one at all. And then they've got a huge list right here. So so they've got a few. They're really trying to just get an understanding of it. Now they really promote this life model, which classifies an injury as if it results in one of the following: life-ending, life-threatening, or life-altering. Yeah, I guess I can get down with that. But I feel like we've skipped some steps here as they're trying to formulate this life model. So injury sustained, is it life-ending? Is it life-threatening? Is it life-altering? And that's when you code it as a CIF or a non-CIF. But the thing is, what about the potential of it? I think that's interesting too. And also, when I think of CIFs, I kind of think more of like catastrophic. So it's like multi-people get hurt due to an incident. And what sort of techniques should we be using? Because we tend to not get the near misses, the first aids that would guide us to something that would be classified as a CIF. So they give us some examples here. They're okay. But still, I'm still a bit confused. Yeah, they're breaking things down. They're trying to justify it. So the conclusion, there will never be a perfect definition, framework, or model. Okay, yeah, I'm down with that. We're in the same boat there. The life model is more of a mature, but it's still based on the outcome. Whereas I thought with the CIF potential, that wouldn't capture it. Life model describes an injury as serious when an injury is not serious. Okay. Okay, there we go. If it's not serious, then it's serious. Life model reduces the noise. Well, so sometimes the noise is important. That would be sort of the gray area. That's what they mean by noise. And then they kind of go off on some stuff. So I just want to really quickly bring in, this is something that I brought into my 683 class. And what's the basis for it is that there is an exposure that will not result in near miss, minor, or major, but will lead to fatality or serious injury. That's what it's all about. That's where it all started. But I didn't see that in the paper. They're saying that there's some stuff that doesn't happen very frequently, but it has a high potential for an outcome. I just didn't see that in that last paper. But anyway, some reasons for CIF: failing to recognize workplace hazards, complacently forgetting about the danger, failure to identify or address human organizational performance, and high-risk situations that are not identified and controlled. So here, I'm actually reviewing the paper here in class. The question is, did it start with Fred Manuel back in 2004? He was taking pot shots at Heinrich, and one of them is this idea that he believes that Heinrich's pyramid indicates if you fix near misses, you'll fix all the other stuff. He didn't say that. You can imply that, but if you turn the page and keep reading, Heinrich clearly indicates that this is just a generalized concept based on data he had available, and that there's value in analyzing cases that don't result in high severity or negative outcomes, because we already investigate those. We already would. As far as prevention, he's not talking about prevention. He's talking about investigate everything. So that's where, Manuel kind of went off, and it struck a chord. And even Dominic Cooper, Dr. Cooper, who's right now on LinkedIn very against HOP. He hates it. He wants everybody just to go back to the original system safety stuff for the most part. He even speaks negatively about safety climate, but he even says here, I'm not sure where it is, but he indicates that Based on his, okay, when analyzing 2 years of contractor incidents, the author found that 90% of potential SIFs were related to routine everyday situations, which basically means it would likely be brought to the attention of management by the workers if you had a really engaged workforce. The percentage of actual SIFs, however, was higher for abnormal events than routine events. So it tends to be a unique thing. So what they're basically saying is if a SIF is typically something that is generated out of, or the potential percent of actual SIFs were higher from abnormal. See, they're non-persistent or rare. So you should have a heightened focus on what could go wrong and do a pre-job task analysis when something's novel or out of the ordinary. High portion of routine SIF precursors related to driving maintenance equipment. So he's even saying, he's almost downplaying it too, that it's not as big a deal as you guys are saying. Oh, what did they say in this one? We're focused on collecting the wrong data. So they are pushing for this idea of, so here's what they're predicating all this stuff on. So what they're saying is fatality rate hasn't gone down much. The incidence rate has gone down a lot. So therefore, maybe we're focusing on the wrong thing. That's kind of the basis for it. But the problem is the units. The fatalities per 100,000, the incidence rates per 100 employees. But they put them on the same scale for dramatic effect. Do you guys want to see what it really is? This is what it really is. That this is actual. I made this. This doesn't move much. You can't even see if this moves or not. So doesn't help much. Doesn't help much. I really wish they would be more honest with this. People go, oh yeah, whatever, right? No, this is really what it is. Okay, and neither really gives us much insight. So SIFs, yeah, a new definition, great. Better understanding, yeah. But I don't think we fully know. There is another paper that's provided to you. I believe it's the Halliwell. Is that right? Yeah, let's see if this one gives you better insight. That's what I challenge. God, these are really good papers. You guys are, whoever your professor is, he's doing a great job. That's it. Otherwise, I was going to look at a safety conference that's coming up this week. But so that's what I really want you to take out of it, that they're trying to come up with a new definition that's good, but they didn't fully understand it. You see that what it's based on is a little bit awry, that OSHA's it's now acknowledging that leading indicators are a good thing, but they don't fully understand it yet. It's because they have a very compliance perspective. That's why. The system safety is designed for engineers, so they understand that an operator is a human. I can say that because I'm an engineer. And then this Lou Sheen guy wrote a paper back in 2006, basically indicating that indeed safety should be managed via quality management technique, and that BLS data is, you can't spell BLS without BS, and that it'd be great if OSHA would improve their record keeping practices. That's all I got for you guys. So go ahead and, you can take a look at these if you want, play around. I would if I were you, but I just kind of gave you the long and short of it, the gist of it. And then now you just have 5 papers to read. But then again, the lecture this week is longer. All right. Come see me in the office hours if you want to talk more about this. Thanks.